Here's problem 1 coming at you. What we're going to talk about tonight here are asymptotes. What those happen to be is when you have a graph, you sometimes have a vertical asymptote where the line comes right up to it but never quite touches it. And then sometimes you have a horizontal asymptote where it comes down, and maybe it's coming down like this, and then it starts going like this. It never quite touches this line. It gets closer and closer to it each time, but it never touches it. That's what an asymptote is. Here we want to figure out with this graph what type of, whether it has a horizontal asymptote and what its vertical asymptote would happen to be. Well, horizontal. Let's talk about that one first. Here's what we're going to Here's what we're going to learn. Whenever we think of horizontal, we have this expression that I taught you. It says Bobo Botten eats DC. Now what the heck is Bobo Botten eats DC? Well, here's what it is, and this is only for the horizontal, only to find that horizontal asymptote. This helps me, it's just a mnemonic device that helps me realize what it is, because you got two options really. The two main ones that are going to happen most of the time is you're either going to have an asymptote right at 0, which is basically on the x-axis, or you're going to have none. Now, this is what this stands for. If it's bigger on the bottom, it's 0. That'll be y equals 0. There'll be a horizontal going like this. If it's bigger on the top, there's none. In this one, if the exponents are the same, you divide the coefficients. We'll explain that in a second. Well, let's look at this guy. Now, this has degree 1, and this guy down here, degree 2. Degree is just the exponents, what their powers happen to be. The largest here is 2, the largest there is 1. So, is this exponent larger than that, or is this one larger than that? Well, it appears that the exponent is bigger on the what? Bottom. That means you and I have a horizontal asymptote at y equals 0. That's right on the x-axis. So we'd say the horizontal asymptote is y equals 0. Now, if these had been flipped, if there was an x squared up here and just x minus 12 on the bottom, then it would be bigger on top, and we say there's none. There is no asymptote. There's no horizontal asymptote. But what about this guy, eats DC? What if this top happened to be a 2? If it were a 2 up there, we would have the exponents are the same. That means we would divide the coefficients. The coefficients are what are out in front of these x squareds. Well, that's a 1 and that's a 1. So it'd be 1 over 1, so then it would have been y equals 1. If it had been a 2 out in front here and a 1 down here, then it would have been y equals 2. It just simply moves that asymptote at 1 or 2 or 3 or 4 or wherever, or even a half. You simply divide the numbers that are out in front. That's what we mean by divide the coefficients. So you have this situation where it's bigger on the bottom, be y 0. If it's bigger on top, none. And if they happen to be the same, then you simply divide the numbers out in front of there to tell you that horizontal asymptote. Now, to determine the vertical asymptote, the one that goes like this, well, what we always look at is the bottom. The bottom can never come out to be 0. So wherever the bottom comes out to be 0, we're going to have a vertical asymptote. So if I look at this, I'm going, wait a second. This x squared minus x minus 12. I've got to make sure that that can't ever come out to be 0. Because if you get a 0 on the bottom, remember you can't do division. And it'll create a problem on the graph. So what we do is I realize, wait a second, this factors. This looks like it's going to factor to an x minus 4 and an x plus 3 that can't come out to be 0. So that means I can't have x be a 4, nor can x be a negative 3. That means on the graph, I've got to draw this vertical line right at 4, and I'm going to draw a vertical line right at negative 3. Because what's going to happen is the graph's going to get right to them, but it can't quite touch them, and it's just going to bend down along them. So to state the vertical, since I know it can't be 4, I'm going to draw a line at x equaling 4. I'm going to draw a line right there where x is 4. If it's on a graph, here's 4. I'm going to draw this line right there. Now, I don't know how the graph's going to do, but something's going to happen to where it's going to come and sort of border it right there. But it cannot touch there at 4. It also couldn't touch here at -3, could it? So we got to draw a line. We tell them also we got to draw a line at x being -3, excuse me, -3. So we draw lines there, asymptotes right there, stating don't touch it. And we also knew there was one right here. Well, that's going to create an interesting graph. It would end up being, well, don't need to worry about that, about out of time with the video, but I'll show you in class how we have an idea of what that looks like. But there you have problem 1, gives you an idea. Remember, horizontal, blah meets DC. Vertical, you have to look at what the bottom of the fraction, the denominator, cannot be. Have a good night.